In this video, we're going to cover 3 learning objectives in section 1.1. Letter D is from a two-way table of counts, answer questions involving marginal and conditional distributions. Letter E is to describe the relationship between two categorical variables by computing the appropriate conditional distribution. And the last one for F is to construct bar graphs to display the relationship between two categorical variables. So let's just first do some vocab about what is a two-way table, what is this word they talked about, marginal distribution, and then we'll get into conditional distribution. So a two-way table describes two different categorical variables. So if we look at this table over here, the two categorical variables that they're looking at is, it looks like here across this row they are talking about gender. So this is the gender, is the first variable. The other variable deals with what is their chances of getting rich. And I know that, by the way, because it says here for getting rich. So there's almost no chance, some chance, and so forth. So those are the two variables this table is looking at. Now, the marginal distribution, what you're going to do, it's of one of the categorical variables in a two-way table of counts. You're going to look at the distribution of the values among all of the individuals described in the table. So in this table, what they did is they computed the marginal distribution of your chances of wealth by gender. Now, if they asked you to make a marginal distribution for this, we could do it with respect to counts or with percentages. This right here is already set up by counts. So the marginal distribution, again, is by your wealth chances, and this would be the total count. Marginals are for totals in the table. Now, what if they want the marginal distribution computing the relative frequencies of those counts? So all I would do is, for example, for almost no chance, we would take the 194 and we would divide it by the total. So this right here represents what if it was a marginal distribution by the percentages. Now we will wrap up our notes talking about how would you make a bar chart for that, and this is just a quick example. So let's dive into an example in your packet. So here we have a superpower example. There is a sample of 200 children from the United Kingdom, ages 9 through 17, was selected from the census at a school website. The gender of each student was recorded, along with which superpower they would most likely like to have. The selections were invisibility, super strength, telepathy, ability to fly, and ability to freeze time. Here are the results. So we are seeing that they did a marginal distribution by superpower. So here's the superpower and here's the total. So that's our marginal distribution of counts. This is a two-way table because we have superpower and we have gender information. So part A, use the data in the table to calculate the marginal distribution in percents of the superpower preference. So what we need to do is take their superpower, take the actual counts, and change them percentages. We do have the total. Again, there were 200 students. If you make the marginal distribution of percents, what it would look like is something of this, and that would meet that requirement. Now let's also talk about, though, what is the variable of interest here being analyzed? The variable of interest is the actual superpower, so that is good to make note. And the marginal distribution that we just created, therefore, is the superpower among the individuals who are females and males. Okay, part B, they want us to make a graph to display the marginal distribution and describe what you see. So we know, again, for making our graph, this is going to be on the horizontal axis. Our labels for the percents will be on the vertical. We're going to make sure to label everything. That particular graph could look something like this. Now, what do we see? A good explanation here, what we could say, is if you analyze this, it looks like here flying and freeze time are maybe the most popular. So a good way to conclude this, you could say flying and freeze time seem about equally popular, followed by telepathy, invisibility, and super strength. That's a good description. Now let's go away from marginal into conditional. So conditional distributions of two-way tables. Again, our two-way table here, we're going to go back to this, the wealth of the students. So we have the wealth and the gender. This is a marginal table right now. Calculate the conditional distribution of opinion. What that's going to do is examine the relationship between gender and opinion. So they want us to look at the conditional distribution of opinion by gender. So conditional distribution of opinion, but by gender. So when you look at the table they've created, they're computing percentages, but how did they compute the percentages? For these males, notice what they did. At no chance, the males were 98. They're going to do it over the entire group of just the males. So they are conditioning it by gender. Same thing for females. So what conditional means is you're not looking at the total table, you're looking at a subset of the table to do your new calculations. In the conditional word is used quite a bit in AP Stats, so you'll want to get more familiar with how to find it. You also see here they made a bar graph. By the way, this is a different kind of bar graph. It is a stacked bar graph, so just another way to see it. So they took all the bars and totaled it up to be 100%. So if we formally define conditional distribution, it is of a variable describes the values of that variable among individuals who have a specific value of another variable. So on here, there is a separate conditional distribution for each value of that other variable. This is actually a little confusing in terms of the vocab. I think the easiest way to figure this out is to think about how do you know which value or variable to actually condition on. And the easiest way to figure this out is just to look at the wording. So if we go back to our superpower example here, they want us to calculate the conditional distribution. So conditional again means a subset of our table. They want a distribution of the responses for the males and the females. So they just told us they want to look at the totals of the responses. So I'm looking at the responses this way. So that's where my totals should tally up, meaning you're going to actually want to go down this way with your data. Sometimes you're going to question yourself is, do we do the totals so they go by the rows? If they wanted us to condition by gender for each response, then we would do that, so that would be different. A good rule of thumb is when you read your statement here, you want a condition of the responses. The first word that follows what they're going to condition by is typically going to be the one where you're going to do the totals down from. So from here, we can go ahead and they want us to do the responses for the percentages. So let's go ahead and do that. If there's 115 females in total, how are we going to find the percent for invisibility? We're just going to do 17 divided by 115, and when we do that, you're going to get 15%. So I'm just going to kind of cheat here and actually put my percentages here for the females. 3 of the 115 is going to be 3%. Then we have 34, 31, 17, and then, of course, 100% is the last one, with my percents there. For the males, the same thing. We have 85 males in total, so for conditioning of the responses by the males, 13 of 85 responded that they want to be invisible, so that would be a 15% total here. Then we have 20, 6, 21, 38, and again, 100. So this here would represent our conditional responses. Let's look at another example for answering some questions about marginal and conditionals. Here we have 200 adults shopping at a supermarket. We're asked about their highest level of education that they had completed or if they were a smoker or not. So here we have the two-way table about education and your smoking, and we see the information here. So this is right here, we see the marginal totals are actually computed. Question 1, what percent of adults with their highest level of education being high school, smoke? What you want to ask yourself about this question is, are they looking at everyone in the table, all 200 respondents, or is it a subset that is a conditional group within this table? So if we read it again, it says here, what percent of adults with their highest level of education being high school? I stop right there. Do they smoke? So I'm actually going to look at those that had the highest level of high school, which is 93. So of that group, how many of them smoke? The answer here is 32 out of 93. And that is going to be about 34.4% of those smoke. This is considered a conditional number because we're not looking at the entire table total. It's a subset. Okay, question 2. What percent of smokers are high school graduates? So here they want the percent of just the smokers. So I stop and I say I'm looking at all the smokers. Of those, how many are high school graduates? We have 32 out of 50. which is going to give us about a 64%. Question 3. What percent of high school graduates are actually smokers? So if we look at this, what percent of the high school graduates are smokers? In this table, everybody is actually a high school graduate. So we are looking at the entire table this time. So it's going to be out of 200. How many of them are smokers? We have the total of 50. So on here, we're going to have 25%. Part 4, how could we display this distribution? So if they wanted us to display this distribution, again, we know the bar graphs are easier, so we would probably make a bar graph. And we could put the years on the horizontal axis. And if we want to display this data, we could have one bar for smokers and one for non-smokers. So a good idea might be to do a side-by-side bar graph. If you were to do that, here's an example of what the side-by-side bar graph could look at. Again, don't forget to label this, put your percentages, and make sure everything is appropriate. Because we are comparing two different responses in here, you need to have a key that tells you which bars stand for which. Okay, let's talk a little bit more about segmented bar graphs. For each category, there is a single bar with segments that correspond to different values. Why are these good to use? The one thing that these are really nice for, so again, we're back to the super strength, and it's male and female, so they have the key, everything is labeled nicely, and it's just a segmented bar graph that's stacked. It does a nice job of actually showing a conditional distribution. Now, one thing about the segmented bar graphs, you do not have to worry about them. This is another type of graph that you're not going to be required to make on the AP exam. If you have to make one, it would be a standard single bar graph, or it could be a side-by-side bar graph. All right, let's talk association. Association are the values of one variable tends to occur more or less frequently in combination with specific values of the other variable. So if one variable changes, is that going to cause another one to be impacted and change? So they kind of move together. They are associated by that. So a question here, what would it mean if there is not an association in this superpower example? So one thing that could mean is that you would not see a strong relationship among the values of the variables. So that is, you wouldn't see a strong relationship between gender and power. Because you might be asked, looking at a particular table or graph, is there an association? And we already talked about earlier that we thought there was an association between gender in that flying and freeze time were more popular by those particular genders. Now, the last thing I want to do is introduce what's called this organizational process that our book likes to use. It is a 4-step process. And what it is, when you're asked to analyze a statistical problem, there's 4 steps you should really go through. And we're just going to start to use this a little bit, and then when we get towards the end of the book, this is what we always do. So the 4-step process is you're going to state what's happening in the problem. You're going to come up with a plan. You're going to do your analysis, and you're going to make a conclusion. So it's state, plan, do, and conclude. So you're going to hear this a lot, and let's do our first problem that uses this 4-step process. So let's go back to the superpowers. Based on our survey data, can we conclude that boys and girls differ in their preference of superpower? That is there an association? You're going to want to give supporting evidence. So what you would first start is you would state what's going on. And what's going on is this. Is there a relationship between gender and superpower? So what superpower would you prefer is the question. What would be our plan to analyze this? Our plan? Well, we suspect that gender might influence a child's opinion about superpowers. So we compare the conditional distributions of response for females alone and for males alone. Basically, let's look at the conditional output of this. Let's look at it in terms of a graph and the numbers. Well, the do part for this, there's a lot, and we've kind of done most of it, but here's what you might summarize. Here's a table and a side-by-side bar graph comparing the opinions of males and females. We'll use percents instead of counts since the number of females and males are different. This is incredibly important that you make note of that. If your counts are not equal, you cannot compare counts. You must compute them to relative frequencies. So here we have a table and here we have a graph. Now we would come on in and just make a conclusion. Our conclusion might be something like this. Based on the sample data, females were much more likely to choose telepathy than males, while males were much more likely to choose super strength or freeze time than females. Females were slightly more likely to choose flying and equally likely to choose visibility. Basically, we're just summarizing what we see as of now. As we get deeper into the chapters, we're going to be more formal in this process. So this is very wordy. Start to get used to it a little bit. And every now and then you will have to do these, mainly in your free response write-ups. So this is the end of our notes. You can go ahead and try your practice problems.